Hello, friends. Hello, friends and faithful followers. Thank you so much for tuning into this video. I'm going to do my very best not to bore anyone to tears. I've made promises with the rest of the people I work with that I will not do that. So we'll see how that goes. But I wanted to talk a little bit about the tech that's going into this. And for those of you who are like me and you're kind of nerdy and enjoy talking about stuff like this, I figured it might be beneficial. So how we're sort of achieving this is we're creating a ball out of mostly foam, and honestly, the hardware side is really not my strong suit. I'm very happy that our guys in manufacturing handle that for me, but they promised me that the ball will be sturdy, and we'll be able to keep everything safe, and all the components. Will be in working order, but I get to play with the software, which is way more fun anyway. So the way we're building this, and I've got a little drawing behind me that I'll get to in a moment, but I just kind of want to show you a little bit of the circuit board. I can't show you too much because it's proprietary, but this is something that you may or may not see inside of your ball once you get it and it arrives, and you can look at it. But what's on that is actually is a processor, a gyroscope, an accelerometer, and obviously the Bluetooth radio that allows the phone to connect to the device. And so then that'll be wrapped into a nice little foam package that you can use for the game. So I guess to talk a little bit more about sort of like the tech that's involved in the back end. Let me see if I can move this up a little bit and not cut my head off. Cool. Okay, so again, since a lot of this is still proprietary and in a patent process, I can't talk at great length about how all of this happens, but I'm going to do my best. So essentially what we're using is right here is you're using your smartphone's camera, and so that's obviously pairing to the ball via Bluetooth. It's a low energy, which is somewhat new, and so that's we put that in there so that we wouldn't waste all the battery of the ball actually just trying to play the game. So there's something to actually plug your phone into, and you can power it for later. But uses your smartphone's camera to recognize objects, and the way it does that is, like I talked about in the intro video, there's a process in artificial intelligence called computer vision. And so computer vision basically takes a look at all the pixels that are in your screen, and depending on the type of machine learning model that you used, we'll run some form of clustering and classification on it. So, I mean, if you're using like an unsupervised machine learner, then you're probably doing some form of clustering. In our case, it's actually classification. So it's a supervised machine learner. We're actually feeding it training data, which would be many photos of the device. So then that way it's able to quickly recognize it. And so because that model is obviously very large, for the most part, it lives in the cloud, and there's a smaller version of it on your phone. And so the cool thing is when a model lives in the cloud, it's able to be updated dynamically. So as more people actually use this device and use the technology, the smarter and better the model gets, which is really great because machine learning isn't still perfect, but it gets better every single time someone uses it, and that's kind of what really makes it great. So we can make that as big as humanly possible in the cloud, and it won't screw up the performance of your phone. And then, obviously the ball also, when tossed, it uses the accelerometer and gyroscope to be able to calculate all sorts of stuff about the ball's flight. So the accelerometer gives you what's called the triaxial acceleration of the device. And so essentially, if you were to picture a device in 3 dimensions, it has an x-axis, a y-axis, and a z-axis, which is coming straight out at you or towards me. And then what happens is there's a force of gravity on it, and if I were to drop this, it would drop straight to the table. So that there was a lot of gravity was pointing straight down. That makes sense because if you were to fall down the stairs, you would obviously tend toward the lower stairs. You wouldn't fall upwards against gravity. So that allows us to be able to figure out where the gravity is on the device, but it doesn't give us a figure of linear acceleration, so it's hard to figure out the device's orientation in 3-dimensional space. And so that's where the gyroscope comes in, and that allows us to get calculations like the pitch, the roll, and the yaw of the device. And once we have that, then we can actually create a trajectory from the toss that's actually made by somebody with the ball, and do some nice animations on screen that use the physics engine of our game, of our game engine, to be able to actually display kind of nice animations, like I said. So yeah, unfortunately, without diving too deep into the nitty gritty, I can't go a whole lot further than that. But if you're fascinated by artificial intelligence like I am, keep studying it. I love it, and yeah, I mean, I hope to be able to do more updates like this in the future where I can give more detail. But if you guys think that this was cool, I mean, let me know in the comments below. And if not, then I probably won't post another one. So thanks so much. Have an awesome day, guys, and we'll see you later.